Is the cat sitting, or is the person walking? What does the person hold in his hand or her hand? And so there is improvement. Of course, it's not like a human performance, but it's getting there. Question answering. I give you a text, and then I have comprehension questions like we have in high school, and also the improvement is getting better and better, close to human performance. Okay? This is thanks to deep learning again. But deep learning is not all perfect. I'll show you some examples where it doesn't work. What do you see here? Come on, what do you see here?
Desert. The desert.
Desert, dunes, sand. You can say many things. Okay? Well, deep learning has been used for real programs that have been deployed already. Since it's good with images, here are images, and we wanted to detect pedophiles. So people who are putting, for example, nude pictures online, well, that is taken for a nude picture. It's desert, come on. And you can show it to a kid and they will know it's desert. So it makes mistakes. Here's another silly mistake. What do you see here? Car. How do you know it's a car? It's a car. It's a funny car, come on. I mean, bizarre design. It's acceptable people make mistakes, but everybody got a car. Okay? I don't see the wheels. Do you see the wheels? But we have some reasoning that is happening in our heads, and we say, yeah, it's a car. Well, do you know what deep learning says? It's a horse. Why? Because there is a horse. There's a horse here. Okay, let's take the car and turn it. Now, do you recognize it? It's a car. It has wheels, and yeah, it's a beautiful car. I will never have a car like that. I'll give it to deep learning. What do you think deep learning would say it's a car now? What do you think the answer would be?
A car.
A car? Well, it's a horse.
Horse.
Actually, it's not even a horse. It's horses. Another horse here, another horse here. These are really silly mistakes. Here are examples of explanations of what's happening in a picture. So the deep learning will say it's a soccer player. The soccer player is kicking a soccer ball. Is he kicking? I don't see him kicking. This is a street sign on the pole in front of a building. Is it in front of a building? Can be on the other side of the street. It's where the photographer is, and they don't, I mean, the AI doesn't see that depth that we can see. Here's another funny mistake. A couple of giraffes standing next to each other. Are they standing next to each other? No. One is far away there. Okay. But it's already amazing results. They're not bad, but they're not perfect. Okay. What do you see here? These are huge challenges for deep learning. Do you see a dog or do you see a bagel? Do you see a chihuahua or a muffin? What if I put them both? A chihuahua and a muffin. Don't try to bite that chicken. Because it may not be chicken. What about that? Is that a mop? So of course it's even difficult for humans. But the people have been working on also tricking the computer to make mistakes on purpose. So here's what a panda looks like. This is what a gibbon looks like. If I take a picture of a panda and I give it to the deep learning, it'll say, yeah, it's a panda, and my confidence is 57.7%. So it's not perfect, but yeah, I have doubts. Okay, because, well, I don't see the full panda, I see part of the panda. Now we add to this image some noise that's not visible to the human. This is what, for me, it looks the same. And for the computer, because of that noise that I added, now suddenly it sees a gibbon. And its confidence goes up to 99%. Oh yeah, let's give it 100%, almost 100%. So just because of this noise becomes a problem. Here's another typical mistake. This was published in 2018. This funny cell-like, it's like the Golgi apparatus, or it's like a cell here, and they added to the image. See this image here? They gave it to the classifier with deep learning. It says, well, it's a banana. Here's my accuracy. It's a banana. It could be other things, a snail, an orange, or a slug. It looks almost like a slug, it could be, but I'm not that confident. I'm very confident it's a banana. That's good. Now, on the picture, I just put that cell-like image, and I give it to the same classifier. Banana goes down. I'm not sure it's a banana, but I think it's a toaster. It's not even a toaster, okay? But it thinks it's a toaster. So yeah, deep learning is amazing, but it still makes mistakes. Silly mistakes that we humans would not do. Even though recognizing melanoma or other medical images like for breast cancer and stuff, it does better than humans. So what is machine learning? Machine learning, because deep learning is part of machine learning. Machine learning provides means to machines or machine programs to learn from data, interpret the trends in the data, and then adapt to the data. What does it mean, it adapts to the data? It means when you give it new data, it can predict to what class it belongs to. And if the data changes because I learned from this data, and it changes, I have new data, I can adapt to it. So it's like learning from experience. I have an experience with the supervision you gave me, now I can predict the future. I saw enough bananas, you show me this banana, it's a different picture, I never saw this picture before, but I'll say it's a banana, because of my experience before. So deep learning is a field of machine learning, and so to illustrate the mechanism, I have this small picture, this animation, to illustrate what's happening. So you have data here that is labeled. And my program, this green thing, passed over it to learn something out of this data. This data is labeled, that's what I have here as colors. Colors represent labels. So I have the class of the blue, the class of the green, the class of the black, the red, and the white. And the algorithm going over it will build a model. The model distinguishes between these different classes. So it's a predictive model to discriminate the classes. I put it as a cloud there. It can be represented by different things. Now I have new data. That was my experience. That's the learning. Now I have new data that hasn't been labeled before. And I use my model to predict their labels. So I saw enough cats and bananas and pandas and whatever. Now I have new pictures. I'll say, oh, that's a banana, that's a panda, that's a... Okay? Or that's an A, that's a B, that's a C, depending upon the data. Oh, this is this word, this is this word, this is this word. So that model can be a neural network. That's what we call it deep learning, but it can be something else, and it's not deep learning. Okay? For example, here we have something we call reinforcement learning. It's something it's part of machine learning, which is a completely different paradigm. The learning in reinforcement learning is not using this framework. It's based on experience, not just supervision, but the experience. I do things. Sometimes they work, then I'll do them again. And sometimes when I do them, they don't work, then I avoid doing them. Because when they work, I get a reward, a positive reward. And when they don't work, I don't get the reward or a negative reward. And my goal is to maximize my reward. Like a child trying to learn, when they do something that works, they get rewarded. You say, oh, fantastic, that's great, or give them a sweet, or we are happy and they like us being happy, or whatever. So that's the reward. They do it again. And when they do something bad, we tell them, don't do that, or that's bad. Then they don't do it again. Okay? They learn, well, what is it? child or another animal, because we have animals too, like a dog, to ask it to roll or sit or whatever. We give them rewards and they learn from that. So reinforcement learning uses that behavioral learning. It's completely different. But what is nice about deep learning, very interesting about deep learning, compared to other algorithms in the realm of supervised learning, the old algorithms that still exist, nevertheless. Here I'm plotting the performance of the algorithm in terms of accuracy, and here the amount of data that I give it. So in the old algorithm, if I give it more data, they get better, but after a while they plateau. They don't know what to do with the data. They don't improve. But deep learning, the more data you give it, the better it gets. And that's why at one point, actually, it does better than humans, okay, for detecting melanoma or something like that. You give it way more data than a human would see in their life. Okay, a doctor would not see all these examples in their life. So here are some examples of applications that you're using already, and you don't know that they're using machine learning. Spam detection. Okay. When you delete an email, you don't even read it. You say, this title, I don't like it. You delete it. The computer has machine learning in the background and looks at your behavior. This email, you opened it and answered it. This email, you opened it and stored it. So it must be important. So they learn the characteristics of these emails. And after a while, it knows what you consider not important and what you consider important. Okay? So it adapts to you. Another example is when you go to ask for a loan from the bank. They have your characteristics, your age, what kind of education you have, whether you own your car or not, where you live, all that information. And they have previous cases with their characteristics and whether they paid the loan or defaulted on the loan. They build a model and then they will predict for you whether you will pay back or not and make the decision, I'll give them the loan or not. Other examples, you buy, every day you buy things and you use your credit card. When there is an authorization that goes to the server, before they say yes or no, they will give you this credit. They'll check that purchase with the purchases you did before. They learned your behavior. Does it match your behavior or not? Okay. So that's also using machine learning. Here are other examples in medicine, and I'll show you examples if we have the time later, maybe next time. For diagnostic, prognosis, treatment recommendation. So this is what we call precision health or precision medicine. Okay. I learned from other cases, from many, many patients we have in our history. I learned a model, and then I have a new patient, and I can predict what kind of treatment I should give, rather than the same pill like everybody else. It's very specific to this case. Here's a very interesting example where you don't even think about it. A paraplegic can't move. Can't move the hands or can't move the legs. But I'm on a wheelchair. I have to have somebody moving me around. What if I want to actually control my wheelchair by myself? So what we do is ask the patient to wiggle, for example, the right toe. And with ECG we can look at the activity in the brain, the signature that is happening when they are thinking about moving the right toe, which they can't because they're paraplegic. Okay? And then we learn that signal compared to other signals. We store that in the training data. Then we ask them, hey, now move your left foot. Okay, we get that signal. Move your right hand. Move your left hand. And we associate the signals that we get to turning left, turning right, go forward, stop, go faster, and so forth. And now, just by thinking to move their, wiggle their right toe, move their left foot, or do these activities that they did during the training, they can actually control their wheelchair. They can also control a cursor on a screen. and choose letters. Now they can write, they can move their hands, they can move their legs, but they can write and communicate. So their quality of life changes completely thanks to machine learning. Reinforcement learning, I just mentioned it. So it's about, basically, you have an environment, you have sets of actions that you can do, okay? And the agent here, I'm representing as a robot, but just a software program, can choose an action to do, and that action is done, and then you have an observer that interprets the environment and says, yeah, this is what happened, this is the new state of the environment, and by the way, here's a reward for what you did. It can be a positive reward or negative reward. And the goal of the agent is to find the policy that tells it what action to choose when, such that I maximize the rewards that I'm getting. Okay? And this is how it ends up learning. Okay? It learns the policy that maximizes the reward when an action is taken. Which action to take in this condition so that my reward is maxed. And we can build robots based on that and many other programs. And the pioneer in this field is Rich Sutton, who is at the U of A, and now is part-time at U of A, part-time with DeepMind, and I don't know if he will give a lecture this semester.
No, but they have to
Look at the videos.
They're still examined on his previous stuff, so it's an important part of the
He's
course.
a very interesting
Yeah.
person. I like him very much, and he has some profound ideas. So here are examples of things we can do with reinforcement learning, and it's something we're doing here at U of A. For example, somebody losing a limb on the battlefield or on the farm or whatever, rather than just putting a simple hook as a prosthetic, we have a more sophisticated arm, and that arm now has reinforcement learning. It learns to adapt to the user. And not just the user is adapting to this new prosthetics, but the prosthetic is also learning to adapt. And now you will choose different action. The action is moving the different articulations and stuff in different conditions. So I will learn that whenever I start moving my arm, for example, to grab something here, it's rather than doing this like a real robot, it'll actually start predicting what I'm going to do, and it'll open my fist and turn, and so it looks way more natural movement, which we do instinctively. We don't think about it. But now, thanks to reinforcement learning, we can do that, also with machines. Before I go precision health, maybe I should stop here and give you a chance to ask questions.
Yep.
Then I'll talk about precision health and many other examples in medicine.
So any questions?
For reinforcement learning, what would artificial intelligence perceive as a reward?
That's a typical question people ask. For the child is to make them happy, whether it's a lollipop or just a smile from the parent. For the dog, you give them something to eat. Or that. For the agent, it's a number. So they want to maximize a certain number. So counter, there's counting 1, 2, 3, 4, 5, and now we have to define what's the reward for different actions. That's a little bit more complicated, but we define it in terms of a number to give. Okay.
Thank you.
Luckily, they don't care about our smiles and our food. Any other question about what is machine learning and should we be afraid of AI? Yes.
Excuse me, I have a question. Let me introduce myself first. I'm Zaiane. I'm an orthopedic surgeon from Nepal. So I'm doing a fellowship in spine surgery at UFA. And then your last slide was interesting because I'm an orthopedic surgeon. We do amputations a lot of times, and back home, we don't have access to all sort of fancy prosthesis. So as you said, we'll end up giving those prostheses with hooks for the upper limb. And most of the time, prosthesis in the upper limb, they are quite useful to the patient because
Yes.
they use it. But for upper limb, it's more like a social or cosmetic kind of prosthesis when they are no more useful. But I've heard and seen a couple of pictures about all those type of fancy prosthesis that you talked about. But I was inquisitive to know, I mean, like, is it only limited to research now, or it has gone to a commercial level where like people can really use it?
They're still very expensive. So those that adapt are still very expensive, so at the research level, as you can imagine, the military is also very interested in that because you have many soldiers coming back with lost arm or leg because of the mines and because of different things, the IEDs. And, there are some companies that start commercializing these, but they're still very expensive. People choose the 3D printed prosthetics that you can still move, but they don't adapt to you. This one is sophisticated because it adapts to you and predicts the movement you're going to do. You're driving a car and you're going to grab the stick to shift. And as you do this, it knows that you're going to go down and grab, so it prepare your hand. Those are not commercialized yet.
I mean, like, how expensive? Because some of the patients like that are well to do, they can afford to have sources of fund.
Compared to, for example, prosthetic that you can move already, and it's a 3D printed, so very cheap, the difference in price is huge. So, for example, this one, this one is 3D printed as well here, but this one is like $1 million.
$1 million.
It's very expensive.
Because sometimes like patients ask us, I mean, like,
Yeah.
where can
These
we
are-
get, like,
these are very
ready to
cheap.
pay,
These are very cheap, and there are even models online that you can download and print them yourself if you have the printer.
Yeah. Thank you for that. And besides that, like, artificial intelligence, I mean, is not totally new to our part of the world also. It's quite useful in health. Like,
Yes.
there are a couple of young guys, Nepalese guys who are training in UK, I think they are doing some project in Nepal. So they are trying to implement this in rural areas of the country. Like,
Yes.
there are no trained manpower. For example, like, there are no expert radiologists in the rural areas. So what they are trying to do is they're trying to integrate the AI with the ultrasound machine for obstetrics. Like, even a layman can just put the probe in the abdomen of a pregnant lady and it gets the data, and then it will give you roughly the information about the fetus which is inside the abdomen.
I'll give you many examples next lecture, but I'll tell you one of the examples that I will not mention on Thursday. I think it's Thursday.
Thursday? Yeah.
Thursday. And it's a project we worked on here at the university. To detect tuberculosis, for example. We are lucky we don't have a lot of tuberculosis here. Actually, cases are coming back now. But in some areas in the world, tuberculosis is a big deal still today. And to do the diagnostic, it's expensive. These guys have to go to the city, and the city at the hospital may or may not have the equipment. So we devised a very cheap tool that you can move to these rural areas. And it's not the sophisticated pulmonary scan or nothing. They have to spit on a petri dish, and that petri dish is left there for a few hours, and we have a camera underneath that looks at the development on this petri dish, and a machine learning algorithm that predicts whether that has tuberculosis or not. It's amazingly cheap, because you just need a PC, it's a laptop, that has the machine learning algorithm is running. The machine learning algorithm is already trained on images of petri dishes from underneath with cases with tuberculosis and cases that are not tuberculosis or control. And now take it in the rural areas, you ask the patient to spit in that thing, you wait there for a day, and then the camera tells you, oh, tuberculosis, yes or no?
Yeah, tuberculosis is a big burden in our country.
Huge in many countries, and so you talked about Nepal, but it's in Thailand and Laos, all that area. There's a lot of tuberculosis.
That's just
there.
interesting.
Yeah. So machine learning can be used in places you don't think about. It's very easy, makes it very simple. It's not the traditional way of doing the diagnostic, but it works and it's cheap.
Thank you.
Yes.
I was curious about using machine learning as it applies to health, just because I think one of the challenges is maybe ethical or I guess data security kind of issues. What kind of
That's
do you
a
have
big
on
deal.
that?
Access to data is a big deal, and access to the right data is another big deal too. The issue of bias. If you're not careful, for example, you have in your training data this ethnicity but not that ethnicity, then your model is completely wrong. Or suppose you have only men, you don't have women. It's completely wrong. So how to deal with that right balance, how to deal with bias in your data is a big deal. But then you have to first access the data. And accessing the data is not easy because the data has been collected for the purpose of treating these people. So they give their consent to collect their data because you're going to treat them for their case they have right now. They never gave the consent to use the data to do research. So that's an issue. It's an issue for us here. It's a huge ethical issue. In other countries, it's not a big deal. I can tell you many examples. I worked on a project with colleagues in China, and we were working on CT pulmonary scans to identify nodules, and I needed images. I didn't care about the patient, I didn't care about the gender, I didn't care about the name or nothing. Just needed the image with the nodules. I couldn't get them here. And my colleagues in China sent them to me by email. It's not a problem. And we were able to do the research. We didn't jeopardize the privacy of anybody. But we are so scared here of lawsuits and stuff like that, that it creates significant hurdles. So how to do it properly is still a big challenge. And sometimes even the doctors themselves don't have access to the data. I'll give you one example. Again, I lived it myself. I had a project with a colleague at the Cross Cancer Institute for prostate cancer. And at one point we asked the question, because we wanted to know, this is again in precision health, we wanted to know what kind of treatment is the most appropriate for this particular patient. Because for some people you give chemo, the others you have radiotherapy, the other one you have ablation. There are different treatments, possible treatments. So these are specialists in radiotherapy. They bombard the cells with X-ray, but that treatment also has side effects. We call them toxicity levels. So they wanted to predict what is the toxicity level that we will have if we treat this particular patient with this treatment. So to detect it, they thought that the best thing to do is to look at the SNPs, SNP, single nucleotide polymorphism. So these are the mutations in the genes. It was really difficult because to get that data for each patient is very expensive. So they had it only for very few patients. It wasn't enough to have an expression in the model. So I asked to add other data. And I said, what if this patient took an antidepressant like 10 years ago because they had a depression? Will it have an impact on the toxicity level for this treatment if we do this radiotherapy? And the doctor said, it's possible, we don't know. So I said, well, put it in. The model will tell you. Not only it'll help us build a good model, but also it gives you new information you didn't know, new discovery. Okay? And he said, unfortunately, I don't have that data, and I don't have access to the data because based on the medical knowledge today, it's actually unethical to get that information. I wasn't in his circle of care when he was treated for depression. So it creates a problem. We have opportunities, and we are killing these opportunities from the start because we are blocking ourselves from accessing this data. I'm not saying we should just ignore the legality and the ethical issues and all that stuff, but we have to find a solution because other people will do it, those who don't care about the ethics and have access to the data. And there are many countries that do that.
In South Africa, when apartheid ended, one of the striking things that happened, everybody was concentrating on human rights. And so people found it's very easy to go to South Africa and do studies you couldn't do anywhere else in the world on primates because no one was looking at that moment. It was just remarkable. It's you know, that, and did that work urgently need to be done in primate? No, it's just kind of an opportunistic thing. Somebody's analyzed the politics and said, I bet nobody's looking at the regulations around primates. Why don't we do it there, you know? So.
But to make the issue even more complicated, if you go today to the hospital and you go in the corridor or in the waiting room or whatever, you ask the patients, can I use your data to do research? They will look at you the same. What? You're not using it already for research? Of course. You go and ask that same patient 10 years later, can I use your data from 10 years ago to do research? They'll say, no, no way. So what happens is that when they need that service, they need the help, they're in a weak position, they tend to say, yes, you can use my data because I need you to help me. But now that I'm healthy and that's behind me, I don't want to think about what happened 10 years ago. I'm suspicious, why do you need my data? No, don't use my data. That's my private stuff. So ethically, it's very hard to answer that question, whether it's the right thing to do or not the right thing to do, even though we know that if we use that data, we'll help society, we'll advance medicine. So, I don't have an answer to that. I know that I will not go and violate their privacy. I know that I will go there to build tools, and but who am I to make that decision? Some other people may have ill ideas and ill intentions. So we need to find the balance. It's a great question. Other questions? Then I'll see you on
Okay.
Thursday.
Thank you for a great teaching session.